Okay, this is the mark scheme for Checkpoint 5 in electric circuits. They work on energy and power, but also some revision of the earlier ideas that we've covered. So our first circuit here has got 3 resistors, each one is 40 ohms. In 2 different arrangements we need the equivalent resistance. So in this circuit we've got 1 over R total is 1 over 40 plus 1 over 40 plus 1 over 40. That's 3 over 40, so RT is 40 over 3, 13.3 ohms. Second one, we've got 2 40 ohm resistors in parallel, so if we do the parallel section, we've got 1 over RP is 1 over 40 plus 1 over 40 is 2 over 40, so the parallel part is 40 divided by 2 is 20 ohms, but then we've got the other 40 ohm resistor as well, so the total resistance is 20 plus 40, 60 ohms. So nice easy start hopefully if we've got confident with our use of finding equivalent resistances. And then we get into applying this, so we've got a different circuit here. Important to notice that these are now 6 ohm resistors, and we've got one possible design here for a car demister where we've got 6 resistors like this. You need to look at this circuit carefully because it might look as if they're 6 in parallel, but hopefully you can see that up here we've got 3 in parallel and they're in series with these 3 down here. So every electron that goes around this circuit goes through one of these 3 resistors, and then later on it goes through one of these 3 resistors. So calculate the current in each single element. Well, there's lots of different ways we can do this. But the safest way to do it really is to say, okay, let's work out the total resistance of the circuit. So for each of the parallel sections, 1 over RP is 1 over 6 plus 1 over 6 plus 1 over 6, which is 3 over 6. So the resistance of the parallel sections is 6 over 3, 2 ohms. There's 2 of them, so the total resistance is 2 plus 2 equals 4 ohms. We connected this to a 12 volt supply here. So the current in the circuit, the current flowing, let's say down here, is 12 over 4, which is 3 amps. Okay, now we could work out that here that they're going to split equally because these are 3 equal resistors. But again, just to give us a more general solution, what we can say is that the resistance of this section we know is 2 ohms. So the PD across this section, if we connect a voltmeter anywhere across there, okay, that's going to read 6 volts. So I've got 6 volts across a 6 ohm resistor. So the current in each resistor, I equals V over R, is 6 over 6, which is 1 amp. Okay, with the aid of a similar calculation, give a reason why the heater would not be as effective as if all 6 are in series. Well, if we had 6 resistors in series, the total resistance would be 36 ohms, so 6 times 6 is 36 ohms. So the current in each element would be I equals V over R, so 12 volts shared between the 36 ohm total resistance gives us 0.33 amps. So if we wanted to work out the power dissipated in each resistor, right, then the best way for us to do this is I squared R. There are lots of other ways you could do this. So in the series circuit, for each one we've got I squared R, which is 0.33 squared times 6, which is 0.66 watts. So we've got 0.66 watts as being the power of each one. We could multiply that up by 6 and we'd find that the total was 4 watts if you wanted to do it that way. If we do the original version, so if we compared that with the one that's been suggested, in this one I squared R is 1 squared times 6, so each one's got 6 watts, so the total would be 6 of those, 36 watts. Question 2, so we've got here a set of decorative lights, Christmas lights, let's say. Each lamp is 5 volts and 0.4 watts, and you want to connect it straight to the mains 230 volt supply. So how many lamps should you put in this set to do this? Well, the easiest way to do this is just to understand that in a parallel circuit the potential differences will add up to the supply. So 230 divided by n, the number of lamps, has got to equal 5. So if we had 2 lamps, there'd be 115 volts across each. If we had 23 lamps, there'd be 10 volts across each. But we need to know this number. So the number of lamps is 230 divided by 5. 46 lamps in the circuit will make them all get 5 volts each if they're in series. What's the current in the circuit? Well, we do I equals, and then you've got a choice here, but probably the easiest way to do this is to say, let's use I equals P over V. So we need 0.4 watts. This is for each lamp, remember, and each lamp is getting 5 volts. So 0.4 divided by 5 is 0.08 amps. So each bulb has to get a current of 0.08 amps. Okay, so same data here. Calculate the resistance of each one. Well, R equals V over I. We said it was 5. We've just worked out 0.08. Again, there's alternative calculations you can do here with the power, for example. Okay, but this is probably the easiest way to do it, I think. And that gives you 62.5 ohms. The total electrical energy transferred by the set of lights in 2 hours. Okay, well, this is an E equals PT. Again, you've got the power already, so you haven't got to use any of those calculations, sort of I squared R or something. We know it's 0.4, but the thing that makes this a little bit tricky is we've got 2 hours. So we've got 2 times 60 times 60. Okay, don't fall into the trap of leaving off one of those 60s. And if you do that, you get 132,000 joules. And then the last part of this question, so when assembling the factory, you inadvertently, accidentally have 10 lamps too many, all connected in series, and each lamp has got the same resistance. Okay, remember that probably isn't true because the current will change the resistance. The lamps won't get as hot, but they're asking you to ignore that factor. So calculate the current in this set of circuit. Well, we've now got 56 bulbs instead of the 46 bulbs that we had first time. And each one of those, we said, had a resistance of 62.5 ohms. That gives you 3,500 ohms as a total resistance. And then we can do I equals V over R, 230 divided by 3,500. And that gives you the current in the circuit as 0.066 amps. Sorry about the writing. Okay, how would the brightness of each lamp in this set compare with the brightness of each lamp in the current set? Interestingly, it doesn't say explain or anything. Okay, so all you need to put is that they will be less bright. Okay, there's less current flowing through each one, and of course there'll also be less potential difference across each one, because now the potential difference is shared between 56 bulbs, so each one's only getting 230 divided by 56. So 2 reasons, if you like, why these lamps are going to be less bright.